Yeah, you need to apply KCL. But what you going to look at first? A nodal analysis. Better I use here. A nodal analysis. Nodal analysis. Basically, you will have maybe some elements and then a voltages, something like this. First, you need to figure out what? An essential nodes, right? So that, why do you need to figure out where's your essential nodes? Because you're going to what? To put a,
Count it.
yes, you need to put a reference node. So over here, this is our example. So where is your essential nodes? You have two, right? First on top here and another one down here. But usually we choose the bottom, right? Why not we choose here, up here? Usually it is because when you look at here, you have a voltage source. When you have a voltage source, it's better to put a reference point, one of its source, so that you avoid what? You're going to avoid what we call here is the super node. Super node. Do you remember what is a super node? Super node is when you have a independent or dependent. As long this is a voltage source, you still remember, right? In between what? In between two unknown, V1, V2, or maybe Vx and Vy. As long this is a voltage source, V source, and it is in between two unknowns, then you call it as a supernode. Okay? So in order for this example, we want to avoid supernode, then we put our what? Our reference point here at the bottom. Okay? So that's number one. Second, what should you do? For nodal analysis. Can you guess? Second,
Name the node.
come again?
Name.
Come again? Name all the nodes, right?
No.
Yes, you name all nodes. So over here, how many nodes you have? Let's see. This is already named, right? What is the name of this node?
Yes.
Zero?
Reference node.
Yes, 0 volts. And what about this point? Is this a node or not?
Yes.
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 Go back to your definition. A node is when you have two elements connected side by side. And in between that is your node. Okay, this is your definition for nodes. So this is a node. We call it as a VS. Why we call it VS?
Same with the source.
Yes, you can actually find it. If you have one point referred to as your V reference, which is 0, then the other side should be the value of your V source. So in this case, the value is Vs, then you put this one as a Vs. Or we can do plus minus. How to plus minus? The higher in polarity should be minus with low in polarity equal to the value of this. So the higher in polarity is Vs minus with the low in polarity, which is 0, should be equal to the value. Yes, the value. So in our case here, this is a Vs. Plus, salah. Oh, minus and 0 eh? Yeah, minus and 0 equal to 0. Sorry. Okay. Alright. Tak apa. Nanti jawab penilap. Okay. Now, this is VS. Second, what is the name for this node?
V1.
V1 or any name, right? You name it. So this is a V1. And then Actually, before you do the what is your essential nodes and the name of the nodes, you need to figure out, do you have a super node or not? This is the most crucial one. Do you have any super node or not? But basically, you cannot figure out your super node unless you do the what? This one, the reference point. Okay. So yeah, back to basic. First, accession nodes, name the reference node. Second, you have to name all the nodes. But in your exam, usually they will give the point, the reference point. So you straight away figure out, do you have your super node or not? If you do have, then you need to use a super node what? A super node approach. What is a super node approach? If you have a super node, then you need to figure out the boundary, right? Boundary for super node. Let's say this is your boundary, something like this. And when you have a super node, you should have two, uh, two what we call it, equations. One for KCL and one for KVL. So what is one for KCL? KCL and KVL. Still remember what is the KCL for SuperNode? If you don't remember, you can go back to your slide. We have done one of the example, right? This example, still remember?
Yes, madam.
Yes, good, very good. So what is your, okay, write down the boundary. And then what else? You need to have KCL and KVL. Okay, and before that, usually we have a 0 here, and this is a 50 reference point, and this is maybe B1, and this is B2. Oh no, we have a V delta here. So in our case here, this is your plus minus B1, and this one is your plus minus B delta. So for KVL, okay, for KVL, okay, KCL, you need to figure out the current direction. But for KVL, you need to do the loops. This is B1, and this is the B1, and plus minus B delta. So the loop is maybe something like this. So your equation should be, maybe start from here, minus B1 plus what? This value, right? V delta over 5 plus V delta over 5 plus V delta equal to 0. So this is your first equation for KCL. KCL, but KVL here. What about KCL? You look at your current direction, which is, this is I1. Enam, ya Allah, 7, 8. So many, eh? Okay, 8. Right. Go back to our sample. 9, 10. Are you guys okay?
Okay, madam.
Yes, madam.
Okay, alhamdulillah. Right. We go back to our example. This is about supernode, how to figure out when you have supernode. Supernode is when you have a voltages in between two unknown, like in our case V1 and V delta. So When you have a super node, you need to have two equations, KCL and KVL. Okay, for KVL, we need to find the loops. In our case here, this loop. And since this node is V1, then you can name this as a V1. Start from minus because this is a ground. And then same as this part, V delta, plus up here, minus here. So you do the minus. Or if you don't want to have this round like this, you can do the normal steps we had, plus minus like this, and this is a V1, and the other side is V delta, and this is V delta over 5, right? The value for this. I said we need to minus the higher in polarity with a lower in polarity and equal to the value of the voltage source. So in our case here, we have V1 higher in polarity minus with V delta low in polarity equal to the value, which is V delta over 5. V delta over 5. Is it the same as this one? The one you had for KVL around the loop? Is it same?
Yes.
Yes, right. Okay, good. So you can choose what method you like. Around the loop or this one. Okay, both acceptable as long the equations are correct. Okay, what about KCL? KCL at this loop. Okay, bukan. KCL at this boundary. Okay, you can name your design. I change the color. Maybe color blue. Okay, so this is I1, and then we have I2 here, and here I3, and here I4. Is it okay, or do you want me to draw a new paper on a new paper?
It would
Okay,
be
ma'am.
easier to follow if it could.
Come again? Come again?
It would be easier to follow if we were to have it on a new.
A new paper. Okay then.
Yeah.
All right.
Thank you.
All right. If you have this plus minus, and then we have something like this, and then this. Do we have any other thing? Yeah, another 78 and 39. 78 and 39 ohms. 39. Okay. Delta over 5. And this is V1, right? V1, yes. V1 and V delta. This is our V delta. This is our V1. And this is 50 volt. Okay, so you can name it I1, I2, I3, and I4. This is KCL at super node. By the way, there's a boundary for this. Let me change the color. Okay, this is a boundary. Then choose this color again. Okay, so what is a KCL? You need to choose current entering equal to current leaving. Okay, which one is current entry?
I
I
want.
I1.
I want
Yes, I want. What about the rest?
living.
Yeah,
Leaving.
yeah, leaving. So this is at the boundary, okay? So I1 is equal to I2 plus I3 plus I4. Okay, so far so good, eh? And then we do the KCL.
Madam,
Hmm,
we do have another resistor.
resistor, mana eh? Hmm,
78, 39, 30,
oh,
10.
We have 10 and 30, right? 10
Ah,
and 30. This is 10, this is 30. Betul? Betul tak?
uh, with parallel. Ada
Parallel.
parallel satu.
This one and this one ke?
No, beside the 30.
Beside the 30. This one done, right? And then
Yes.
10
Atas.
here. Uh-uh.
There's
Oh,
another 10.
10. Oh, here.
Ah, yeah.
So actually, this one, you don't consider this because why? Can you guess
Uh,
why?
because the I is same.
Because no, no, it's because of you look at the boundary. This is a boundary, right?
Oh,
Okay. Whatever attached to the boundary. So in this case, this is our attached wire, right? And this one also the attached wire, and this one also the attached wire, and this is the last attached wire at this boundary. Okay. So you just
okay.
consider on that. Uh, the rest, it will come using another equations. So in our case here, we proceed with KCL. Uh, okay, 50 minus with V1, right? Do you remember this? You need to minus the higher impolarity with the lower impolarity and then divide by resistor value. Okay, so in our case here, we have 50, oops, 50 minus V1 divide by 10. Okay, equal to, what is I2? V1. V1 is high in polarity. How do you know? Because ground always zero, which is minus here. Okay, lower in polarity. So here we have a higher in polarity. So V1 minus 0 equal to divide by 30 second. Plus, what is I3? Higher minus with lower in polarity, which is V?
V delta.
Yes, V delta over 39. You can actually
39.
combine these two, 39 and 78. Yes, you can do it. But if you don't mind, you can do this way also can. Okay, 70 divided by 78. Mm. Alright. So far so good?
Yes.
Mm. And,
Yes.
and over here, you need to solve all the, what we call here, denominator yang bawah tu kan. So just simplify it and then you get some equation here. Okay? Alright. So in our case here, actually we just touch on the super nodes because why? Because here this is about nodal analysis. Nodal analysis, you need to first figure out the essential nodes and then you name that nodes, usually at the bottom. Second, yes, you need to name all the nodes and then you figure out. Number three, the third steps is to have, is there any supernode or not? If there is, then you need to apply both KCL and KVL. Okay? And then fourth, you need to figure out the, give the current direction. You guys okay? Assalamualaikum.
Yeah, okay.
Yeah,
Okay,
all
okay,
right.
madam.
Okay, madam.
Yeah.
Okay. Yeah, good. In my class, I always do the horizontal to the right and the vertical to the bottom, going down. Okay, so it's up to you. As long you follow what? Passive sign convention. Still remember, right? What is passive sign convention? For,
Yes.
for passive element, you should have a current entering positive and current leaving negative. This is passive. But for active, you should have entering a negative and leaving a positive. Okay, now done with chapter pula cepatnya. Done with supernode and nodal analysis. Okay, so far do you have any question? Oh, another important thing about supernode when you have a voltage source, this is a dependent, okay, in between two unknowns, and if you have something, an element like this, any element, sometimes R, sometimes C, sometimes L, in parallel with this voltage source, in parallel, dependent or independent supernode. Okay. What is independent? The circle size, something like this. As long as this is in parallel with each other, then you need to consider both as a super node. Okay, both as a super node. This is only applicable for voltage source in parallel with element. Why we call it in parallel? Why we consider both as a supernode? Why? Because you know you recall to the last thing we had, any elements in parallel with something, you should have what? Same?
Same voltage.
Yes, same voltages.
Yeah.
That's why we need to consider as a one boundary. Okay? But for your super mesh, it's a little bit different. You have a independent or dependent current source. Okay, current source. And if you have some element in series with this, in series, okay, in series, then you should consider this as your what? Super mesh. Super mesh. Yeah, we will do this revision. So that's our main agenda, because I want you to recall why this is in series. Why we have current, yeah, current in series should have the same, right? So that's why you need to consider both. Consider both. Okay, same current. All right. So we go to our mesh analysis. Mesh analysis is when you have a loop. Basically, it handles the loops. Okay, let's see. We have this example. Voltage, current. Okay, voltage and current. Okay, we have something like this. Tak cantik. Sorry. This is current. Okay. Right. First, what should we do for mesh analysis? First is when you need to
Look one,
identify.
two, huh?
Yes, you need to identify all what we call this imaginary current loops. Okay, so let's say this is I1, I2, and I3. Okay, next, what should you do? Apply what? You need to identify another one is a super mesh. Okay, do we need to put a reference point? Reference equal to
No.
0? No, because this is a super mesh. Only the loops, the closed loop. Okay, second, you need to identify super mesh. What is a super mesh? When you have a current source in between two, macam as long this is a current source, either dependent or independent. This one is a independent. Okay, in between two closed loop, Maybe this is I2 and this is I3. Then you need to consider the boundary here. Okay. So for our previous case, Yanni, I made some mistake here. You need to put some a closed loop, a closed loop, something like this. So you have two closed loop like this. Then you need to consider the whole thing here as your um, a mesh loop, a super mesh loop. Same as this part, you have two, but you need to consider uh, to include this part, this element too, because both having the same current together. So far so good?
Yes.
Okay, you can interrupt me. So if you have independent or dependent current source in between two, maybe I put some element here, two closed loop, then you can have a super mesh. Super mesh. So this is your imaginary mesh, imaginary super mesh. Okay. And what do you need to do when you have a super mesh? Same as previous super node. You need to have one is KVL around super mesh, and another one is your KCL around at the super mesh. So for our case here, we have we didn't specify any value. This is 3, 80, and 5. This is 80, 5, and 3. Okay. So when you have apa dulu? KCL lah. Okay, something like this. Okay. This is KCL. Okay. So the name tells you, right? What is KCL? You can do two ways. First, either you do the normal one. Okay, the normal one. So this current is entering, coming from where? From this. Okay, and then this current is leaving, which is equal to 3 amps, and this current is this way, which is I2. So you can do the KCL. KCL, this one at super mesh is equal to current entering, which is I3 equal to this one. Better I put different color. This one, and this one.
Means
3.
3 ampere minus I2.
Yes. Okay, that's number one. Or you can do the one I teach you in the class. This is 3, and look at the direction of the current of your imaginary loop. So current, the same current, which is I3, minus with the opposite in current, which is I2, should be equal to 3. Since we don't have space here, I just put here 3. Is this the same or not?
Yes, it's the same.
Yeah. Okay. So which one you prefer? Up to you. You can use any method that you like, as long both are correct. Okay. This one coming from here and this one coming from here. All right. What is KVL around super mesh then? KVL around super mesh. You look at the boundary here. You have a boundary, right? So for this, you do the the math around the boundary. We have here 80 and 5 here. Oh, kejap. We have another one, which is here. What is this one? We go back to here. We have 10. 10, 80, and 5. 10, 80, and 5. Here, 10, 80, and 5. This is 10, 80, 3. This is 5. I3, I2. Okay, and this is I1. Right. So we start from maybe the easiest one, 5. Okay, KVL around the loop. 5 into this imaginary current, which is I3. Okay, what we want to find? A voltage, right? A voltage. So if you want to find a voltage, voltage is equal to IR. So obviously you need to have resistor and current. So here 5 is the resistor and I3 is your current. In 5 into I3, and then what else? You need to go through this boundary, okay? So according to this, you're going to meet what? 10. Second one is 10. Plus, how do I know a plus or not? Can you guess? It's actually coming
The
from,
current flow.
yes, current flow. Since our current flow is going to here, and we're going to have a passive element, you should have what? A positive, right? A positive. Into a passive element should have a positive, and leaving it should have a negative. So since we have here a positive, then you need to have the oh sorry, over here you have a plus, and then over here you're going to enter a passive element, which is a plus here, plus, and then you have a 10 into I2 minus I1. Why do I minus I1? You look back at your circuit here. Yeah, you have 4 and 144. Here 4 and here 144. Another loops, right? So you need to choose the your main loop first, minus with the opposite loops. Okay, and then plus again we are entering a passive element, which is resistor 80. Then we need to have a plus here. Then that's why you have a plus 80 into I2. Oops, I2. And then equal to 0. Okay, so far so good.
Yes.
Do you have any
Yes.
question? No, eh? Alhamdulillah. Okay, and then you simplify this one, 5I3 plus 10I2 plus 80. So you have a 90I2 minus 10I1 equal to 0. Something like this. Okay, so this is a second equation. The first equation is this one. Okay, so far so good. But you look at the how many unknowns here. You have 1, 2, 3, right? Here 1, 2, 3. So we need another equations coming from where?
The
KCL.
first loop.
First loop. So first loop is 144 with 4 ohms, right? This is 4 ohms. This is 144 volts. And you have here something else. Apa? 10. 10. Oh, ada lagi. Baru masuk. 10. Okay. Siapa baru masuk tu? How are you? This is I1 and this is
Bagus.
I2. Okay. So according to our imaginary current direction, we start from here and you use what? The polarity that you see first, like this one, negative, right? So you have a negative 144, and then you're going to enter this 4 ohms. Since this is a passive element, you should have a positive here, and then you're going to enter 10. Since this is a passive element, 10 is a passive element, you have a positive here. So you have a plus 4. And remember, this is a K, V, L. So you need to find V, a voltage. 4 is a resistor. Okay? Voltage is equal to IR. Then you need to find current at here. So what is current through 4 ohms?
I1.
Yay. Yes, I1. And then plus 10. But since this 10,
I1.
yeah, 10 here is sharing with 2 loops, right? Remember, there's 2 loops here. So we need to consider both loops. Now, then 10, and our focus is at I1, then you should have I1 first. And then minus with the sharing one, I2, or the opposite one, equal to 0. Why equal to 0? Because we have finished looping this. Okay. Then our equation will be equal to 144. And this is 14 I1 minus 10 I2. Then this is your third equation. So I think by here you can finish the yeah, you already revised the super mesh. Do you have any questions? But the basic is you go back to here. Yes, first identify all imaginary current loops. Second, identify if you have any super mesh or not. If yes, then you need to consider KVL and KCL. All right, and then consider all 1, 2, 3. But do you still remember? Because last time I test you guys. What if we have the last loop, something like only current? We have a very complicated circuit, maybe something like this. Maybe, yeah, here. This is a voltage. This is 3 amps. What do you think? Current at I3. What is the equation at I3?
3M.
3 amps
Negative 3
or
amps.
Minus
yeah,
3.
Negative
yes,
3M.
yes. Okay. So this loop should have this current. If you give me this, straight away 2 marks. Don't build any equation around the loops. Okay? Because you will get wrong. You just give this value. Right? So this is the most crucial part, I think. The rest, this and this, you apply the normal concept. Okay? Any question? Ada soalan?
Madam,
Yes.
was there any mesh for this last example?
In this exam, I
No,
believe
last
there
example.
will.
I mean the last example.
Oh, the last
That you was just,
example.
yes. Was
You
there any
asked,
mesh?
oh, mesh. Was
Yeah.
that any
The
mesh?
last one.
Oh, the last one.
Yeah.
You asking me the super mesh or mesh only?
Both. Is there any super mesh or mesh?
Okay. What is a super mesh? What is a super mesh? When you
Super
have
Current.
mesh.
what?
Current which, yeah,
Current source in
placed
between
between two loops.
two closed loop, right? Two closed loop. So if you have this, then you have a super mesh. Do you have it here or not?
No.
No, right? No. So there's no super mesh here. But do you have a mesh? Imaginary mesh. What is a mesh? A closed loop, right? So this is one closed loop, and this is another closed loop. So you should just give a name, I1, I2, right? So there is a KVL of this mesh, and for I2 and I1, so that you can answer all the question here. Okay. All right. Another question? So far so good, or maybe you have something you are not clear. If you still not clear, you can private message me. Don't worry. No.
Madam,
Yes. A bit.
kalau nodal analysis, kalau dia tak jadi super node, kita pakai
Yes. You
KCL nya
just
madam.
use KCL if there is no super node. Betul.
Kalau match sama juga pakai KVL. Kalau dia jadi super node, super match boleh kita pakai dua-dua
If you don't have any super mesh, also you use only mesh, the normal mesh.
Oh, okay. Thank you madam.
Okay. So your job is to find is there any super mesh or super node in your circuit. If there is none, then you just apply the normal one. Okay. But the basic concept of this chapter is to master by doing some exercise so that you know which one and which one is a super mesh or not, or super node or not. And you need to understand where to apply nodal analysis or mesh analysis. Okay. Afif already left. All right. Do you have any other questions? Alhamdulillah, Hamza. Okay. If there is none, we stop here. And I already gave you the links. First, the links, because our next class will be chapter 4. So try your best to understand first before coming to the class. And then we just, you can propose me any example, then we can do in this session. Okay. All right.
Okay, madam.
Okay. So we finish our class with Tasbih Kafarah and Suratul Al-As. Subhanakallahumma wa bihamdik, asyhadu an la ilaha illa anta, astaghfiruka wa atubu ilaik. Wal 'asr, innal insana lafi khusr, illa alladhina amanu wa 'amilus solihat wa tawassaw bil haqq wa tawassaw bis sabr. Alhamdulillahi rabbil alamin. Pray for me. I'm going to catch my train actually. Yes. Siapa tadi tu?
Thank you, madam.
You download
Thank you madam.
this
Stay safe madam.
video.
Yes.
Madam.
Niza, you want to say something? Sama-sama.
Have you upload this
Thank you
recording?
madam.
Yes. Actually, I'm going to upload, but because of my mobile data is limited, so I'm KIV. Today I'm going to travel to Ipoh, my home. So that's unified, and maybe by then I can upload to you guys, inshallah. But please remind me, keep on remind me, okay?
Okay, thank you, madam.
Yeah, most welcome. Okay, Assalamualaikum everyone. Bye.
Waalaikumsalam.
Sekejap, saya kena tutup je. Stop recording.